All right, exchange papers, please. Number one, that's what we should see.
Do they have to have it colored in, or just, if they just have the graph from 1 to 4, or 1 to 2? Since it's divided in halves, they just have 1 to 2.
Isn't the rate of change 1/2?
Excuse me?
Isn't the rate of change 1/2?
Mm-hmm.
Do they have to have the rectangles?
Should. It says, sketch R and partition it into 4 subregions with each with a base of length x, delta x equals 1/2. Number 2, left ram approximation 3.75. 3.75. Number 3, mid ram approximation 4.125.
If they have it in fraction form?
In fraction form, that would be fine. So what is that? That's be 33 over 8 for number 3, is that correct?
Yes, so what number 2?
Number 2, 3 and 3, 4, so it's gonna be 12, 15 over 4.
Okay. But they had 770 over 16, but I'm thinking that would be
Should be reduced.
Okay.
Number 4, right ram 3.75.
So
15 over
left
4.
ram and right ram are the same.
Mm-hmm.
Pretty sure he did have definitions for 2 people.
No, I think he did, it's just number 2 did reduce it.
Number 12, letter A, should be the integral from 0 to 10 of x cubed dx. The integral from 0 to 10 x cubed dx. Letter B, integral from 0 to 10 x sine x dx. Number C, integral from 0 to 10 x times 3x minus 2 squared dx. Letter D, integral from 0 to 10 of 1 over 1 plus x squared dx. And letter E, the integral from 0 to 10 of pi times 9 minus sine squared of pi x over 10 dx.
Can you repeat D?
D, integral from 0 to 10 of 1 over 1 plus x squared dx. Number 14,
Use 13.
13 rather, I'm sorry, 13. Number 13 should have 10. Should see a diagram with a using your area formulas. Should get 10. Using areas.
Can you do number 13 on the board?
Yeah, I didn't get that. It was over.
Alright, so if we draw this out, 4 minus x. Alright, so you got two triangles. Alright, so this triangle here should be 1/2 base times height. This triangle here should be 1/2 base times height. This triangle here, the base is 4. The height is 4. The area is 8. This triangle here, the base is 2. Oops. Area, the height is 2. The area is 2. Alright? Therefore, the area is going to be,
Wouldn't it be 6? Cause 8 minus 2? This
yeah,
is-
according to what we said, what I talked about the other day, but I didn't get to finish it, yes, it is 6. So if they have 6, it's fine.
It is fine,
Yeah. Technically, the area though is 10 between the curves. Because the area of this is 8, the area of this is 2, so the actual area between the curves and the line is 10. But we'll talk about that. But according to what we talked about the other day, yes, I told you that below is negative, above is positive. When you add those, you get 6. If they have that. All right, put a plus number correct on the top for me, please.
What is 12 D wrong?
No.
Pass it back, please. Any other questions?
I don't know what I was doing for
Anybody have any other questions?
Wait, so land only has to do with curves. So we give it.
Well, everything's a curve.
Because if it's a straight line.
It's still a curve.
It's straight.
Correct. So all your functions will be curved. Although if it's a straight line, then your approximation is more accurate than an actual curve. But even if you have a straight line, you use the rectangular approximation method, it's still gonna be overestimated or underestimated, because you're still gonna have part of your rectangles above or below. If you use areas like we did and talked about in the second lesson, then it's more accurate. So. Anybody else, any other questions? All right, pass those forward, please. Where's yours?
Will 13 be on the quiz?
13, yes.
And do you want us to add it like how we did for the homeless just now, or subtract it?
Let me talk about that a little bit more.
Okay.
All right, turn to page 279. again, we're dealing with definite integrals. Something we didn't get to the other day is, we started talking about where the area underneath the x-axis ends up being a negative area. But again, when we deal with integrals, we're looking for the area underneath the curve between the x-axis and the curve. That's basically what we're looking for. So if we take the areas and make it the area underneath the curve a negative area, then they're going to cancel each other out. Which integrals will do that somewhat sometimes. But if we're actually looking for the area, then we need to make that negative area positive. So, when we have something like this, let's look at f of x dx from a to b. And this is my graph here. My integral is basically going to equal the integral from a to b of the negative of f of x dx. So if we make the area that's underneath the curve the opposite, in other words, we're changing it to positive. So whereas the problem that we did on the homework, which you did it correctly according to what we talked about the other day, you did fine, all right? But technically we want to make sure if we're looking for the area between the x-axis and the curve, we want to make sure those negative areas become positive. So we want to change the sign. So what happens when we have what we saw on our homework, when we have this type of area? We're going to divide up the two areas like we did here, and if this is A to B to C, to get the correct area when we're dealing with integrals, we're going to take the integral from A to B of f of x dx minus the integral from B to C f of x dx. To make sure that this negative is not being canceled out with something here, to actually find the area underneath the curve. So as we get into integrals, we're going to find out that we're going to have to make sure that we find out where our zeros are to be able to separate that function to do that. And we know our zero here is at b, so we can separate our two integrals to two different integrals, which we would end up doing the same thing. All right, so we're down in the second box there. It says f from the integral from a to b of f of x dx equals the area above the x-axis minus the area below the x-axis. Because we know the area below the x-axis is going to be a negative area. So we want to make that positive, so that's why we subtract that. And so there's the difference there. So that's part of the other day that we did not get to when we got there. So if we look at Theorem 2, which we sort of know this already, Theorem 2, the integral from f of x dx from a to b equals from a to b c dx. All right? Because of a constant, if I have a constant here, say this constant here is f of x of equals 5. And I want to find the area from 0 to 6. Well, using my area formulas here, how do I find the area? All right, length times width, which my length is 6, my height is 5, which is 30. Well, by this theorem it says the integral from a to b of f of x dx, when f of x is a constant, that's going to be the integral of, let's do this differently here, that is going to be equal c of b minus a, because f of x equals c. And that's all it is, because f of x is 5, so this is 5, and b minus a is 6, which equals 30. So anytime that we have a constant, it's going to be very easy to do, because I can take my constant and multiply by the difference of my boundaries, if you want to say, or my limits, as they call them, the limits. All right, so if you take out your calculator, there is a function on your calculator that you can find integrals. And when you see it in your book, it's called NINT. NINT, integral. You will find it underneath math. So if you look at your math button, you should see INT, integral.
With FN.
Yeah, I have F and I too.
Yes, that's it.
Okay.
Yep. The one above that is your derivative. So if you do 5 from 6 to 8, you press that button. Yep, dx. So you're gonna put your function in, so you're gonna put 5.
Oh, you.
Yep. And the x equals. Alright, because the distance from 6 to 8 is
2.
2, and then times the 5. We ever get it? Your calculator's still dead? Oh, the one I just said, from 6 to 8. 5 dx equals 10. Alright. Let's do this one now. This was 4 minus x. And we were doing it from, what, 0 to 6? Alright, so let's do this one now. 0 to 6. 4 minus x dx. Now, when you do this, you're going to find out your answer is going to end up being 6. Because the integral, when we do the integral, all right, it doesn't take into effect the top and the bottom. They don't make this negative a positive. So they'll actually get 6 like you did earlier. But if I actually want to find the total area, then I have to keep that in mind to find out where it crosses the x-axis. Because if I go from 0 to 4, right? If you go from 0 to 4, you should get 8. With that same function, 4 minus x. You should get 8. So it gives it direct above the curve.
So if you did from 4 to 6, would it give you a negative?
It should give you a negative 2. All right, and you can try that. Okay? So anytime they ask you to use NINT, you can use your calculator. But we're also going to do it algebraically as well using our integral formula. If you look on page 285, 285. Some rules for definite integrals. A lot of our rules for integrals are the same as our rules for derivatives. Say for instance, normally our limits are my integral, smallest to biggest. Alright, smallest to biggest would normally give us a positive or a value. But if we switch these around, biggest to smallest, I get the same value but opposite sign. So if this equaled a positive, this would equal a negative. Or if this equaled a negative, this would equal a positive. So that's how they get the theorem there, order of integration. The integral from b to a, f of x dx, equals the opposite of a to b, f of x dx. Okay? So it makes a difference on how you put your limits of integration, as these are called, your limits of integration. The smallest on the bottom, usually the biggest on the top, is usually the way you want to do it. If my limits, if my limits are the same, right, the integration, the area between the curve would be 0, because there would not be any area between that. Just makes sense there. Constant multiple. So if I have the integral from a to b of 5x dx, well, that is the same thing as 5 times the integral from a to b of x dx. I can just take the constant out. A lot of times we don't have to, but we could to make it easier. All right, just like my derivative. If I want to take the derivative of x squared, of 5x squared, I can take away the 5, and that would be 2x, and multiplied by the 5 is 10x. Which a lot of times we didn't have to do that, because we just took the 2 and multiplied by the 5. So we didn't necessarily have to do that. Same thing if we have a minus sign inside. So if I have the integral from a to b of negative f of x dx, I can bring the negative sign out. That would be the same thing as the negative of the integral from a to b of f of x dx. Same thing. And again, I've been putting them on the outside. They have them on the inside. I've seen it both ways. Most likely, it's probably should be on the inside. Actually, that's where you're gonna see it mostly. I don't know why I've been putting them on the outside, but I've seen them both ways. Sum of difference, just like our derivatives. If we have a sum of difference, the integral from a to b of f of x plus g of x dx. That is the same thing as the integral from a to b of f of x dx plus the integral from a to b of g of x dx. All right, so let's flip over to page 290. Let's look at number 2. It says suppose that f and h are continuous functions and that the integral from 1 to 9 f of x dx equals negative 1. The integral from 7 to 9 f of x dx equals 5. And the integral from 7 to 9 h of x dx equals 4. So we're going to use those concepts to be able to figure out the integrals below. So letter A, the integral from 1 to 9 of negative 2 f of x dx. Well, our constant rule says we can take the constant out and the negative 2 out. What is the integral from 1 to 9 of f of x dx? Negative 1. And then I would multiply it back, which would be equal to 2. Alright, so basically what we did, 1 to 9, negative 2, f of x dx. What would that say that equaled? That equaled negative 1. And we multiply that by the negative 2 that's on the other side. Gives us 2. Letter B. The f of x from 7 to, or the integral from 7 to 9 of f of x plus h of x dx. Well, we can separate that. What's the integral 7 to 9 of f of x? 5. What's the integral of h of x from 7 to 9? 4. So what are they two added together? 9. So these properties are very much similar to our properties of derivatives. Letter C. The integral from 7 to 9 of 2 f of x. What does that equal?
Oh, sorry,
From 7 to 9,
yeah.
2 f of x would equal what?
Wait, oh, 7 to 9, oh, 5, oh, no, times 2 is 10.
Alright, everybody with me? Okay. What does 3h of x equal? 12. So 10 minus 12. Negative 2. Letter D. Alright, the limit, or the integral from 9 to 1, f of x dx. Well, what happened to the limits here? We switched them. So therefore, what happens to the integral? We're going to make it the opposite. So the integral from 1 to 9 was negative 1. So the integral from 9 to 1 would be 1. Letter E. 1 to 7. Well, this one's a little bit different. Because the integral from 1 to 9 would equal the integral from 1 to 7 plus the integral from 7 to 9. Alright, basically this is what we're looking at. Here's my area of the whole thing. If I divide that up, alright, here's 0 to 5 to 7. So the area between 0 and 7, that's the same thing as the area from 0 to 5 and 5 to 7, added together. Alright? So this is just like an equation. They're asking me to find this one. So that's going to be the integral from 1 to 9 minus the integral from 7 to 9. What's the integral of f of x from 1 to 9? Negative 1. Minus, what is the integral of f of x from 7 to 9? 4. Which gives me,
Isn't it 5?
what is it?
Isn't it 5? Because this is f of x, not h of x. Or is it h of x?
No, f of x.
Okay, then it's 5.
So that gives me what? Negative 6. So again, we're taking our basic math concepts and applying it to our integrals concepts. Everybody see what we did here? Alright, we just kind of pieced it together, 1 to 9. They connect like a puzzle, 1 to 7, 7 to 9. There's no gaps in between. Alright, I'm looking for this one, so I take this over here and subtract it, and I get my new number. Letter F. The integral from 9 to 7. What did I do to my limits? Switch them around. So this would be the opposite of 7 to 9. What's my limit from 7 to 9 of h of x? It's 4, so if I switch it, it's going to be negative 4. And what's my limit of f of x? It's 5, so it would be negative 5. So therefore I have negative 4 minus negative 5, which would be 1. And that's how we're using our properties to be able to calculate my limits and stuff. Anybody have any questions so far? Okay? let's say the limit from a to b of f of x dx equals 5. Let me change this a to b to 0. Not 0, do 2 to 8. The average mean value theorem states that if I want the average mean value of this integral, that is going to equal 1 over b minus a times the integral from a to b of f of x dx. So we're going to evaluate the integral, and then we're going to multiply it by the reciprocal of the difference between my two limits. And that's the mean value theorem for integrals. So in this case, all right, the difference between my limits is 6, so it's be 1 over 6 times whatever the integral of my f of x is, which is
Oh, it's gonna be, oh, so 5.
5, so it's going to be 5 over 6 would be my mean value. Turn to page,
So it just takes the average of what
somewhat, yes,
space. Or,
close, but not exactly, but close.
So is it finding the area, or is it finding?
We're still finding the integral, but we're trying to find the mean value. Sort of like the average, that middle. Is basically what we're trying to find.
The middle,
Of the area.
so like where, okay, so, yeah, so on the graph, if you had a triangle, like the mean value would be like in the center.
Somewhat, yes.
Okay.
So, we're going to look at an example here. Let me see if I can find it here. Alright, 31 and 36. Find the average value of the function on the interval using antiderivatives to compute the integral. We're going to use our NIT here. Alright, so let's look at y equals sine x. Alright, so that means we're going to do the integral of sine x dx from 0 to pi. And I want the mean value. Well, that's going to be 1 over pi minus 0. It's always 1 over b minus a times whatever the value of this is. So use our calculator. Use NINT.
Do we multiply it by, okay.
I get 2.
Everybody get 2? So when we multiply by 1 over pi, I get 2 over pi. Look at number 13. If I find the average value of the function on the interval, at what points in the interval does the function assume its average value? Okay, so this is a little bit more, more of an extension to that. So we got the integral of x squared minus 1 dx. We're going from what? What's my limits?
How did you do?
So what kind of number?
We are on number 11.
Okay. So, 0,
do to nine.
that's a square root of 3.
Yeah, you got that.
You guys good?
And then I just put in zero.
How do we get 2?
I put in 0 to pi. And then, what was it?
Sine x?
Sine x, yeah. And then-
Let's see.
Yeah, that's what I got when I got in, when I.
Yeah,
put
he was
it-
in degrees.
When I put it in degrees.
Okay, so it's 1/b minus a. And the.
I got you.
Get you now?
Yeah.
Okay, good. Again, we're on number 11.
So we're finding the average integral of that.
Yep. That's gonna be 1 over square root of 3 minus 0 times whatever the value of that integral is.
So d of x is the derivative, right? So it's.
That's a
yeah.
change in x, yes.
So why wouldn't we put like 2x?
Well, we're getting there.
Oh,
But we're just gonna use NIT right now. So NIT of x squared minus 1 from 0 to square root of 3. What do we get?
2.35 times 10 is a negative 14.
Alright, and multiply that by 1 over square root of 3.
Oh, that was,
That was,
yeah. The integral is 4.0703 times 10 to the negative 14. And then divide that by square root of
Do you put the x squared minus 1 in parentheses?
mhm.
3. Well, it's already in parentheses.
Yeah, I have the 4.07.
Alright, what is just the NIT of x squared minus 1 from 0 to square root of 3?
Square root of 4.0703
Times 10 to the what?
negative 14.
To the negative 14th.
Yeah.
Alright, so basically what they're saying there is basically it's gonna be 0.
Oh,
So the negative 14th is like 13 zeros in front of that number, so it's basically 0. Okay,
Okay.
and we'll see what's gonna happen here in just a second. So 0 times 1 over square root of 3 is
yeah.
0. So let's say, okay, at what point does the mean value, this function, equal the mean value? So we're gonna take our function, set it to equal what the mean value is. Okay? And solve for x. Alright, we're looking from 0 to square root of 3, so at what point am I looking at? 1. So it says, at what point in the interval does the function assume its average value? Well, it equals its average value at 1. And again, if I look at this, this is my graph. Right? And I'm going from there to square root of 3. So when I look at my areas, okay, where does it equal my mean value? It tells me it equals my mean value at 1. And so that's basically what we're looking for. Now, that's using NIT, but we want to get out of the habit of that because we see what happened when I did NINT. It gave me a decimal, but it's really going to be 0. And let's look at that. Because this is the derivative, and my function is always going to be the integral of f of b minus f of a. I'll change this here. A to b. So basically we want to find the antiderivative. If I'm looking for the antiderivative of this, it's the opposite of the derivative. How do I find the derivative? Take the exponent, multiply it to the front, subtract 1. And we learn how to find antiderivative. How do we learn how to find antiderivative?
By adding 1 to the top and dividing the constant by, or the coefficient by.
Correct. So we got x squared. So we add 1 to the exponent. 3. Divide by x cubed over 3. Minus antiderivative of 1 would be x.
And then plus c.
Well, plus c, but I don't have to worry about plus c here because I'm definite. Alright, so now what I would do square root of 3 cubed over 3 minus square root of 3 minus 0 over 3 minus 0. But when I do that, 3 squared of 3 cubed is
3 squared.
over 3, which is square root of 3, minus square root of 3, which is 0, minus which this is
0,
0. So therefore my integral equals
0.
0. Using antiderivatives. Okay? So we'll talk more about this tomorrow. So basically what I want you to do tonight for homework is your quiz. So let me give you that. If I can find out, remember where I put it.
What was the chemistry homework?
It was the worksheet he gave us
Okay.
to do all of it. The ideal law worksheet.